Good afternoon. Today we have the subunit of unit shift in the field method in geography. That's your types and sources of data. In the types of data, we have basically two types of data. Number one is the spatial data and second one is the non-spatial data. In the spatial data, we discuss about or we take the earth surface features, that is the geometry. So suppose you have a village, then it's the village location, it's a point. And where is the ATM? That's the location at a point. So post office, likewise, the geographic features we represent as a point on the basis of their latitude, longitude. That's a location data. Then the river, road, pipelines, they also form a type of spatial data. Then the third one is the area, the geographic area, say Papumpare district or Arunachal Pradesh or the India. Likewise, you have also the forest area, a soil extent, like that. The other one is the non-spatial data. Non-spatial data are the characteristics of the geographic features which are there in the spatial data part. So like name of the district, then rank in the healthcare or the literacy. Then we have like population of the district. Likewise, we have a variety of non-spatial data. Then when we are talking of spatial and non-spatial data, we must understand the dimension as well as the levels of measurement used in these two types of data. In the point data, as you said, is the location, that is 0D. We take only a XY coordinate pair. So this X and Y are basically the longitude, that's X, and the latitude, that is your Y. Then the next one is the line data, that's a one dimension. It has the length, no width, what we represent as in your cartographic procedures. So drawing a line for the river, so it has XY coordinates sequences, X1, Y1, X2, Y2, likewise up to Xn, Yn. Then we have the polygon, that's the two-dimensional data. That's your area. Area is in terms of XY coordinates, XY, X1, Y1, X2, Y2, X3, Y3, then Xn, Yn, then X1, Y1, that means completing or enclosing the feature. Then you have the surface, that's 2.5D, where the elevation is taken. Say in case of DEM or the tin model is represented, we see only the surface. We cannot see, we don't have any idea about the internal part of it. But when you are talking of the volume, that's a 3D, we have X, Y, and then the Z. Z may have separate, or for any particular XY location, we can have different Z, say different layers, say soil horizons. So A, B, C, likewise there are horizons, we can have the depth. Then in the non-spatial, the attribute one, we have nominal, that's the name, then the ordinal, then that's the rank, interval, and ratio. In the nominal, we have rank. For the example, the road is NH 152 or NH1, like that. We are naming the road only, that means the feature has the name. Then is the rank. So depending upon the use or priority or the rank, say expressway can be 1, national highway 2, the state highway 3, likewise we can give them the rank. Then the third one is the interval, the distance between two places. Wherever you start, it doesn't matter. Say in the case of temperature, same temperature like in Fahrenheit, 32 degree is melting point of ice, and 212 degree is the vaporization point. But in Celsius, it is 0 and 100. So these are all intervals. Okay. Then the ratio is actually a number that allows all sort of mathematical operations to be carried out. So like you have total road length, it has an absolute 0. So no road means it's 0. So likewise we have different types of representations, levels of measurement as well as the geometry. So then the spatial data models. In the spatial data models, if you see this map, then if you will see this is Arunachal and the boundaries are crisp. This is a typical and accurate geometry. Then the other one is the raster data model. If you see, it follows a certain pattern. That means it is made up of grids only. There is no sharp boundary. It does not represent the complete geometry. Definitely it has certain representations. Then in the vector, what we have in the vector? We have a coordinate system. In that we have projection. You can have latitude, longitude, that's a degree, minute, second, or you can have meter as in the UTM projection. Then you have the datum. Then we have the extent, geographic extent. Then the XY coordinate pairs. In terms of point, only one. Sequences like line, and its polygon x1 y1 xn yn, then x1 y1 again. Then we have the XYZ coordinate system. Basically it is used for the altitude models. It can also be used for any other values like temperature, rainfall, air pressure, many things, or even population, literacy. All those things can be modeled with the Z for any particular point. Then in the raster, coordinate system is there as equivalent to the vector system. In addition to that, it has the cell. That means what should be the cell dimension? Is the cell can be represented. So it's a point here. Then here the same point is a cell. Here it is the line. Then the same is here as the connected cells. Then this is the area, and you have the cluster of cells. So likewise the two data models are different and have their own capabilities as well as the limitations. Then besides that, we have image data. The satellite images we use extensively. So we have satellite images as well as the aerial photographs. Aerial photographs have the capability to show the third dimension. We use mirror stereoscope and get the third dimension. We can measure the elevation by using parallax bar. So the aerial photographs are very much important in geographic studies. Then we have the panchromatic. Panchromatic means it has the full spectrum, that means visible spectrum, VIVG YOR, that means 0.4 to 0.7 micron in the EMR. So we have only one value. Then it is in the grayscale. Then the second one is the natural color composites. Basically it's a combination of what? 3 colors. So you have primary colors like blue, yellow, red, and it is displayed with the help of color scheme, that is your RGB, red, green, blue. Then the false color composite, because we cannot see beyond the 0.7 micron, that means we cannot see infrared. So infrared part is included in the imaging in the FCC. So that is why it is called FCC, the false color composite, because we are able to see the thermal part, infrared part as per the map composition. Then the second one is the digital image. We have a single band. Panchromatics are single band. Then multispectral, we have different bands, band 1, band 2, band 3. Then you have the hyperspectral. There are hundreds of spectral bands. Then you have the LIDAR also, which is now extensively used for geographic analysis. Then the non-spatial data. Non-spatial data basically are, as you said, is the characteristics or the attributes. Name of the countries, states, districts, blocks. Whenever you are saying the name, then it's a nominal. You can have the river name also. Then you have the town name, village name, all this. Then area, population, number of factories, forest, agriculture, air, water quality of a particular area, then literacy, workers, income, education, all these. Say for the agriculture you have cultivated area, cereal crops, pulses, production and yield. If you see data table like this, this is for the Papumpare. Okay, so how much is the rice area production? That means for Papumpare district, the rice cultivated area. Geographically it will not show the exact area or on the ground, rather it is a statistics. So these are all non-spatial data. Within Papumpare, how much is area is used for different crops. Then as we are using varieties of data, a lot of sources are also there for this data. Either you can have the primary sources or you can have secondary sources. You have gone to the field work, you collected primary data. So we start with the surveying, because in your bachelor's degree courses you have gone through the surveying. So how you survey? So chain and tape survey, you use different instruments, then you measure the length and finally you get the map. So likewise you have the plane table survey, then you have prismatic compass survey, dumpy level survey, theodolite survey. So all these are basically used to generate spatial data, but the demerit is that it has no lat long. So only you can have a scale but not the orientation or the direction, north direction, or say orientation simply. Then the sources of data is the toposheets, because toposheets are accurate based on the variety of surveys, geodetic survey, field survey, also from the aerial photographs. So all are collected and Survey of India produces the toposheets at various scale. It is gone up to 1:50,000, which is the common, then 1:25,000. So they are trying to update it, and we can have this from the Nakshe. So like this first thing. So this is the Survey of India Nakshe website. Then you have the website name as soinakshe.uk.gov.in. For that you need to have Aadhaar as well as your mobile number. You should keep handy to download the data. You have to enter your Aadhaar number, then you will get the OTP. Then after getting OTP you can continue with your downloading. So you have to register. Then the next is your aerial photographs. Aerial photographs, as you know, these are very restricted. Those provide high quality spatial data for the photographs. So Ministry of Defence, Government of India is providing permission to map, or you can say photograph the area, or nowadays even the drones are used. So anyway you have to get the permission from the Ministry of Defence or this aerialphoto.in, they will get for you. Then next is your image data source. Image data source are many. So you have Bhuvan for India. This is list 3 image that is in public domain, free of cost, open source. You can get from 2008 onwards up to 2017 it has been updated. So you can have like this the Survey of India Bhuvan portal interface. So it is easy. So this is like you get, see, you are getting 18th December 2008 then up to 25th November 2017 for the Itanagar area. So what you can get, the SCATSAT, then OceanSat, ResourceSat, then hyperspectral, then Cartosat, then ResourceSat AWIPS. Basically, we will go for this list 3, which is our intended source of satellite image data. Then image data source others, USGS Earth Explorer. That means you can get satellite images starting from 1976 onwards and global coverage. You will get Landsat 7, Landsat 8, many other sensors. So this is the list of the sensors. Aerial imagery you may not get for India. Then DEM you can get SRTM DEM. Then many other. So likewise you will get, again this is the interface through which you can select and download. You need to register for it. Then the other raster data sources like DEM. DEM is a digital elevation model. As you have already done in your 3rd semester, you had used contours to generate DEM, but that is for your limited area and may not be accurate because you are deriving it from the contours at 1:50,000 scale. So SRTM provides then subtle, this SRTM is 90 meter, then Raster GDEM is 30 meter, ALOS pulsar gives you at 12.5 meter, then the Cartosat DEM is at 30 meter. This is one of the best ways, that is CGIAR, CGIAR. So it provides like this. You can select your grid, click and get it. This is the one of the easiest way to download DEM. Likewise, this is the interface for the DEM in Bhuvan. Okay. Then next we will go for other data source like socio-economic data. Socio-economic data, you have the SEDAC, that's global scale. You have it in the GIS format: agriculture, health, population, property, sustainability, and many of you have been instructed to download the village level data for India. It is available 1991 and 2001. As you said, this is the Sikkim area. I have already sent you this as the KML file or KMZ file as well as the SAFE file. You can use it in your QGIS. So then you have this Bhuvan thematic data source like land use, land cover, soil, geomorphology, wasteland, flood hazard. All these are available in this Bhuvan app1.nrsc.gov.in. So if you can go to the Bhuvan and get it like this from here. So you can see the thematic services. Yes, from there you can download the required images. We'll discuss how you will get it little later. Then others are like Diva GIS. This is country wise data available. Is in that administrative units up to district level. You additionally have road, railway like this. So you have Diva GIS. So this is a Diva GIS map for the northeast. So if you see, this is Arunachal. This is the old outline of districts. Now it is 25 districts: Tawang, Bomdila, Separ, like this. These are district headquarters. So you can have a lot of data including the population. Then we'll go for other data sources like vector data, drainage. So you have USGS hydro. In that you can have continent wise hydrological network. Also it's provided by the global river network, green. So these are the interface, and the website's address or the link is given here, you can see. Then other sources of spatial data is your WMS and WFS, web map services and web feature services. In the web map services you get the map data, that is you can get a printout. It will be in the either JPEG or TIFF format. So if you want to use it for QGIS or ArcGIS, then again you have to digitize, first georeference and digitize. But in case of web feature data, it comes as the feature with geometry, and you can see this is the link for the web map service for the Bhuvan. So you can get so many information about this. Where you are getting? We are getting in the web service. So this is the geomorphology for the Sikkim part. See this is Sikkim geomorphology 2005-6, that year it was mapped, and Sikkim East District. So you can see like this. Also you can download it. Then we go for the next, that is your non-spatial data sources. There are so many. Administrative unit wise data, chronological data, that is time series data for any specific area or the district, event specific data, the tabular data, data matrix you can have soft copy as well as hard copy. Government departments mostly provide this sort of data. Then research products also do their own sample survey and publish, like NSSO. Then the gazetteers. So there are so many, www.data.gov.in. Then this is for the UNESCO data. So there are so many, as per your requirement, data type you want. So it is mostly available in the net. So then one of the major source of data in India with regard to population characteristics, demography, is the census. So in the census you can have maps also and data. So you have Arunachal here. Then what are the data we get? That is on the basis of their tables. First one is the A series data, general population tables. B series data, economic. C is the socio-cultural. D is the migration. F is the fertility. H is the household tables. H is the houses, household amenities. SC/ST series for the scheduled caste and scheduled tribe linked data. So you have a variety of data from the census, which are non-spatial data. Another source for the non-spatial data for the Northeast especially is the NEDFI. Obviously it is collected from the government sources of the states, so it's adequate and provides a good amount of data for the scholars to work. So it covers population, economy, agriculture, horticulture, sericulture, education, handloom, handicraft, forest, fishery, animal husbandry, then transport, telecom, health, banking, industry. I think for your research work this will be helpful. Then the non-spatial data sources are like climate data, IMD, India Water Portal data. So India Water Portal provides like this, indiawaterportal.org/metadata. So you can select the state, select the district, data type you want, like temperature, precipitation, humidity, cloudiness, cloud cover, and you can have also starting year to end year. It provides 1901 to 2002. Rest data you can get from the IMD portal. Obviously you get last 5 years data, and for the rest you have to request and use their order form so that you get the data from them. I think this should be sufficient, and if any difficulties you can ask me. Thank you.